Alright guys, there has been some confusion with when it comes to reducing fractions. So I'm going to try to explain it a little bit differently. I want to introduce you to a definition or a vocabulary known as divisibility. Basically, divisibility is when one number can be divided by another and the result is an exact whole number. Okay, so you're probably asking, what do you mean by that? All right, let me give you an example. Say I have the number 15, right? I have the number 15. 15, let me see if I can put it on a different color. 15 is divisible. 15 is divisible by 3. Okay? So 15 is divisible by 3. The reason 15 is divisible by 3 is because, say I go ahead and divide 3 divided by 15. So let's just go ahead and divide that real quick. 3 divided by 15, or 3 can go into 15 5 times. 3 times 5 is 15. I have a remainder of 0. Because I have a remainder of 0, then 15 is divisible by 3. Because if I were to divide 15 and 3, it would give me no remainder. 3 would easily go into 15 5 times. Now, let me give you another example. If I had, say I had the number, let me think, say I have the number 9. All right, say I have the number 9. 9 is not, so 9 is not divisible by 2. So say I gave you the numbers 9 and 2, and I said, and I asked you, hey, is 9 divisible by 2? The answer is no. 9 is not divisible by 2. The reason 9 is not divisible by 2 is because if I were to divide 2 and 9, 2 goes into 9 4 times. 2 times 4 is 8. Subtract 9 minus 8 is 1. So check this out. I have a remainder of 1. Since I have a remainder, 9 is not going to be divisible by 2. Another way of seeing that is something, this is another way of looking at it more visually. Say if I had 9 oranges. So here's my little oranges. 1, 2, 3, 4, 5, 6, 7, 8, 9. I have my 9 oranges. If I were to go ahead and divide my 9 oranges by 2, I have 1 pair, 2 pairs, 3 pairs, 4 pairs. But guess what? This guy right here is left over. Whenever something is left over or as a remainder, it is not going to be divisible. So 2 will go into 9 4 times, but it's going to give me a remainder, so it's not going to be divisible. The only times that a number is divisible by another number, say 3 or 2 or 7, etc., then you cannot have a remainder in the end. It has to be a whole number. I have to have a whole number. So let me talk about what this video is really about, and it's simplifying. The reason I talked about divisibility is because divisibility has a lot to do with simplifying fractions. So for example, or actually if you read here, it says simplify by checking if the top and bottom is divisible by 2, 3, 5, and 7. The reason I have specific numbers here, the reason I have specifically 2, 3, 5, and 7 is because if I'm trying to simplify a fraction, say if I have the fraction, let me think of a fraction. Say if I have the fraction 2 over 8. 2 over 8, okay? And I'm trying to simplify this. I want to first check if it's divisible by 2. So the top and bottom both have to be divisible by 2. In other words, 2 has to be able to fit into 2 or 8 evenly. That's the key word, evenly, without any remainders. So if we go ahead and check, 2 is divisible by 2, because if I were to go ahead and do 2 divided by 2, 2 goes into 1 time, 2 times 1 is 2, and I have a remainder of 0. If I were to go ahead and do 2 divided by 8, 2 goes into 8 4 times, 2 times 4 is 8, I have a remainder of 0. So since I have a remainder of 0, then I already know that the 8 is divisible by 2. So I'm going to go ahead and divide both the top and bottom by 2, since 2 is divisible, and that would give me 1 over 4. Now that is considered simplified, so that is my simplified answer. Now the reason, back to earlier when I mentioned the reason I have 2, 3, 5, and 7 is because if you've tried to check if any of these 4 numbers are divisible by the numerator and the denominator, if none of these numbers fit into the numerator or the denominator, then chances are it's already at its most simplest form, and you don't have to simplify any further. And then if you're asking, but Mr. Ortiz, how about 4? Can I check 4? Well, the thing is, 4 is divisible by 2, so we're kind of that wouldn't work out, because since 4 is divisible by 2, I mean, we're just doing extra work on our part. And then also 6 is also divisible by 2. We're trying to find the least common denominator whenever we're trying to solve a fraction problem. So you can't really use that either. But yes, 2, 3, 5, and 7. If none of those 4 numbers is divisible by your numerator or your denominator, well, chances are it's probably already at its most simplest form. I'm going to go ahead and give you another example. Say I have 3 over 9. Say I have 3 over 9. Well, let's start with 2 here. Let's start with 2. Is 2 divisible by 3? It's not, because if I were to divide it out, I'd get a remainder of 1. It's not going to work out. Is 2 divisible by 9? It's not, because again, I'm going to get a remainder of 1. So let's move on to the next one. 3. Is 3 divisible by 3? Yes, it is, because 3 can go into 3 one time. So 3 divided by 3, and whatever I do to the bottom, I must do to the top, or vice versa. 3 is 1. 3 divided by 3 is 1. 9 divided by 3 is 3. So the simplified form is going to be 1 over 3. Now, remember what I said earlier. Both the top and bottom have to be divisible. So say I have something like this, 2 over 9. Well, first I want to go ahead and check, is 2 divisible by 2? It is. Is 2 divisible by 9? It's not. So guess what? I got to move on to the next number. How about 3? Is 3 divisible by 2? It's not. But guess what? It's divisible by 9. But unfortunately, that doesn't really matter because they both the numerator and the denominator have to be divisible by 3. 5, nope, neither is divisible by 5. 7, nope, neither is divisible by 7, sorry. So 2 over 9 is already at my most simplest form, so I don't have to go any further. Okay? So guys, just remember, if you're trying to simplify, check these 4 numbers up here. Is it divisible by 2? Is the top and bottom divisible by 2? If not, try 3. If not, try 5. If not, try 7. If you've already gone through all those 4 numbers and you still can't find a number that's divisible by both the numerator and the denominator, then chances are it's already in its simplest form. All right.